Let's start with this one then. Right, so show how the deanery value minus 15.75 can be represented as a normalized floating point binary number. Always got to take special care, the number of bits. So 8 bits for the mantissa. So our final answer has to be 8 bits for the mantissa, and then 4 bits for the exponent. And it says you must show you're working. They're not doing that because they think you're going to cheat and use a calculator, because you ain't going to be able to do that. They want to award you points for getting through the process but maybe messing up the last bit. Alright, so that is really important. Right, our first thing is we know we got a minus number, and it's going to be 2's complement. What's interesting, it doesn't say that there, does it? But hey, so we'll assume it's 2's complement. Right, so we're not going to go for writing down what minus 15.75 is. We need to do plus. So we're going to do fixed point first. So we're going to put a binary point. We've got to write down positive 15. So we need enough columns so that we can put a sign bit of 0. So 1, 2, 4, 8 would be enough to put 15, but not positive 15. So we need a further column. Put your sign in first. If you want to be explicit to the reader, write sign next to it. But don't put it below it, because you're going to do some stuff below it in a minute. Right, so we want to write down 15. So 15 is all the ones. Right, we want 3/4. So 3/4 is going to involve a half and a quarter. I could put an 8 if I wanted, but there's no point. I'll just be putting a 0. So I'm going to write that. Now, I could leave it like that, but I want the examiner to know what I'm doing. So I'm going to put in brackets plus 15.75. I'm now going to do 2's complement just like I do. This is really an integer, isn't it? It's just that I'm saying, oh, between those final 2 bits, I'm pretending there's a binary point. So all the things that we do with integers is just the same here. So I'm going to do flip and add to get my minus 15.75. Remember, with the flip and add, flip until you get to the last one, the least significant one, and leave that as a 1. So in this case, I could just put myself a little note and say, hey, that's the last one. So I'm going to do my flip. So flip, and you know you've done something right if you end up with a sign bit of 1, because you've got a negative. Flip, 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 flip. Make sure you put your binary point. The binary points are critical to keep making sure you write them down. Flip, that's the last one, so we leave it as a 1. But I'm going to tell the examiner that I've got minus 15.75 now. So I've done the fixed point. Now what I've got to do is normalise it. So to normalise, we're looking to remove duplicate sign bits. So we're looking for it to go a 1 straight away followed by 0. That's where we want to put the binary point. So if we look from the left hand side, from the most significant bit, look for the last copy of the sign bit. In this case, the last copy of the sign bit is there, so that's where my binary point is going. So I'm going to move 1, 2, 3, 4, and I'm going to put an arrowhead on, and I'm never going to stop saying this, so that I can show that I have moved that binary point 4 places to the left. At this point, even if I can't do the rest of the question, I can tell what the exponent is. So I've now got an exponent, and I'm going to write that exponent. It's 4, because I moved it 4 places. But what I've done by moving left, I've shrunk that number. And I know I was going to do that because I started with a number that was bigger than 1. So my exponent needs to be positive to make that number enlarge when we read it back. So it's plus 4. I know I'm using 4 bits, so I can just write this down. It's 2's complement. So I'm not going to be a hero. I'm going to put 4 bits down. I'm going to put my sign bit in, 0 for positive. Then I'm going to write 4, and I'm not going to mess it up. And I'm just going to put next to that exponent, in case they weren't clear. Okay, so I could have done an arrow going down saying, look, there it is in binary. Right, what I've now got to do is write this number out cleanly. Okay, so I'm going to write 1. I don't have to put the point, but I'm going to put it just for my sake. And then I need to count carefully. So I've got 4 zeros. I've got another 0, and I've got a 1. Now, they've designed this question quite well, which is unusual for the exam board. We've got 1, 2, 3, 4, 5, 6, 7 bits. When I'm padding on the right, I've got to pad with a 0. I've got to have 8 bits. That is my mantissa. So I'm going to write mantissa. The annotation is critical. If you just spray a load of 1s and 0s around, there's no way anyone's going to follow it. And they ain't going to waste time following it either. That's critical. Anyone got any questions about that one? It is just dumbass mistakes, really, isn't it? When you mess these up, they're not hard. It is just, oh, I didn't follow the process properly, or I didn't look, or I can't remember what it was, and I won't ask you to hold up. Somebody wrote 4 down wrong.
Oh yeah, no. I put 0, 0, 1, 0.
Yeah, but you know, you've got to get into the habit of double checking any working out that you've done. When you get to the end of the paper and you've got like 5-10 minutes left, go back and check, because you'll never believe the amount of stupid. Look at me whenever I'm going through these questions. You're always going, yeah, you cut that up. Yeah, it's easy to do, isn't it?
When do you pad with a 1?
Right, you never pad with a 1.
You never.
No, I'm saying that in a certain way.
Okay.
If you need to pad on the left hand side, you sign extend. So whatever it was, so if it was a negative number, the left you would repeat the sign bit.
Is that when you're adding?
Yeah, when we're doing adding and we want to make sure they're the same length after the binary point, and you go, oh, I'm missing a few, you need to extend the sign bit. So that's why I wouldn't say you pad it with a 1.
No.
You pad it with what the sign bit is. If it's negative, pad it with a 1. If it's positive, pad it with a 0.
So in this scenario, you always pad with a 0 when it's on the right.
Always on the right, it's a 0. Doesn't matter what the number is. Okay.
You put a little weird 1 on one of my mantissas. I don't know why.
Did I add a bit?
No. It's just there. It's actually right, but it's there.
Had you cut the sign up?
No.
Hmm.
Is that where the
Hang on, let me just